day 8, we're going to go back to circles a little bit. So we're going to refresh ourselves on some vocab from last unit. It's not going to be as crazy as last unit circles-wise, but we do need to refresh ourselves on some circles vocab. This first whole top section is the definition of circle, radius, chord, diameter. Hopefully you know those. Those are kind of just there for you to reference if you need them, but I'm going to skip over that little section because I'm assuming that we know what those things are. Then we go into some more detailed vocab, some stuff maybe we haven't heard before. This first definition here is called concentric circles. They're basically circles that are like nested inside of one another. Most importantly, concentric circles have the same center. So both of these circles, they're nested inside of each other. They both share that center point A. And then next we're going to talk a little bit about arcs, which we have already talked about, but let's refresh ourselves one more time on some of this vocab. A central angle is an angle that's vertex is on the center of the circle. Remember, all of the central angles added together all make 360 degrees in total. And then each central angle will cut a piece of an arc. So the arc is created by the end points of that central angle. And then remember, our property about central angles and arcs is that if I have a central angle, let's call this 100 degrees, then my arc measure is the same exact angle measure. So if that's 100 degrees, this arc is 100 degrees. We remember that from last unit. I'm going to skip the next one really quickly because it's basically the same thing. We have a bunch of different kinds of arcs. We have minor arcs. Minor arcs are arcs that are less than 180 degrees. Okay, so smaller than a semicircle. And when we talk about minor arcs, to denote that something is a minor arc, we usually name it with 2 letters. So the 2 letters, I would call this arc AB. Opposite to a minor arc is a major arc. A major arc is greater than 180. And remember, we also can denote major arcs by the number of letters. We're going to use 3 letters to denote a major arc. So I would call this arc ADB. Same thing with semicircles. They equal exactly 180. We can use 3 letters for those as well. So that would be arc ADB as well. Vocab that's familiar? Yes, we kind of remember that from last unit. There's an extra little postulate in here, which is just kind of like one of those common sense postulates. It says that if I have an arc that's made up of other pieces, I can add the 2 smaller pieces together to get one big piece. That's literally all that postulate up there says. It says, I'm going to take this arc, ZY and YX. I'm going to add them together to get the measure of arc XYZ. That's all that says. Any questions on that? Okay, let's get into the new stuff. New but not new is the term circumference. We've probably heard circumference before. Circumference is I'm going to do this in a color here. Circumference represents the length of the pizza crust. It's measured in centimeters, inches, feet, whatever it is. It's a unit of distance, just like we measure with a tape measure. We have 2 formulas for circumference. They're interchangeable. It kind of just depends on what information we have in a problem. We can either say, probably the most common one that you see is circumference equals 2 pi times the radius. But because we have that 2 times the radius, we know 2 times a radius is a diameter. So we can interchange that with this formula, which is pi times the diameter. They mean the same thing. They just use either diameter or 2 radii, which are the exact same. Good there? So then the new concept that we're kind of adding on to that, because I'm sure you already know about circumference, the new concept is called arc length. Now I need to make an important distinction here. Arc length represents the length of the crust of one slice of your pizza. This is, again, measured in centimeters, inches, and feet. we are going to see examples that ask for arc length, and then we are also going to see examples that ask for something called arc measure, and the two things are different. So off to the side here, I'm going to write arc measure. And we're going to see that used with like an M, a lowercase m for measure, and that's always measured in degrees. So let's back it up here. Let me zoom out a little bit. When I'm talking about these measurements of these arcs, like in these vocab examples up here, I'm always talking about their arc measure. They're measured in degrees. This would be like, 270 degrees, something like that. When I start talking about arc length in this unit, please understand I am not asking for the degree measure of those arcs anymore. I'm asking for their literal length. If we were to take a pizza crust, take a tape measure and measure it in centimeters, inches, feet, whatever it is. Do you understand that distinction? Okay. For the formula, it's quite simple, actually. We take the circumference formula of one full circle, one full pizza, and then we're going to multiply it by whatever fraction or whatever portion of my pizza I'm looking at. So let's take a look at this example here. 2 pi r represents the whole circumference. And then, x out of 360 tells me what portion of the whole circle it is. So let's put some numbers in here. Let's say that x is 90 degrees. It's not quite, but we're going to pretend. Okay? And then I told you to find this. Arc length is always denoted with like an L. Usually it's like a cursive L. So it's saying, find me the arc length of that pizza slice that's 90 degrees. So I would say, I could either say 90 out of a total 360 degrees, because it's 360 all the way around, or if you're good at fractions, you know that 90 out of 360 is the same thing as 1/4 of your pizza slice. Because we're putting these in our calculators, it really doesn't matter whether you use 90 out of 360 or 1 out of 4. Either way, let's give this radius a value. Let's call it 2. I would do either 90 out of 360 times 2 pi times the radius, or 1/4 times 2 pi times the radius. So the blue is 1 full circumference. The green tells me how much of that pizza slice I cut off. Does that make sense? Okay. Other questions on circumference and arc length? Okay, flip it over. We're going to do the same thing with area. So that same idea. Hopefully the area formula is familiar to us. It's pi r squared to find the area of a circle. Okay, that r is the only part that's squared, not the pi. You never square the pi. An area of a circle, we're going to call this the area of the pizza. Area is always measured in units squared. So centimeters squared, inches squared, feet squared. And then here's the new vocab. We call this area of a sector. Make sure you highlight that word sector because it's going to come up again. Sector area is like the area of one slice. And again, it's measured in centimeters squared, inches squared, feet squared, just like area of the whole circle. Exactly like that arc length formula. In order to find the area of a slice, I'm going to find the area of the whole pizza, and I'm going to multiply it by whatever portion of the circle I'm looking at. What portion? So out of a total 360 degrees again. So let's say that that's like 60 degrees for this angle over here. I would be looking at 60 out of 360, or I could simplify that to 1/6 if I'm good at fractions, times, all right, let's give this another 2, pi r squared, pi r squared, whatever method you like to use. You're putting it all in your calculator anyway, so it doesn't really matter if you simplify that fraction. Good. Okay, let's talk examples. I'm going to bubble this in for us really quickly. Oop, oop. What I want you to notice about this section that I just bubbled in is that in every single one of these questions, I either see the word measure or I see an M. We see those? That's telling me I'm looking at arc measure, and the measure tells me my answers should be in degrees. It is very, very important that we are keeping an eye out for measure versus length. So if it says in number 1, find the measure of these arcs, I'm going to go back to what unit was that? Unit 10, where we did circles, and I'm going to think about all of those properties. So let's knock these out really quickly. They shouldn't be too bad. The measure of arc XY is talking about this full arc right here. So I'm going to do 56 plus 40 to get 96 degrees. DXM, I'm going to erase this. DXM goes this way. I see it's one full semicircle, so 180 plus 56. 180 plus 56, 236. Yes, we remember. Let's keep going. Only a few more. YCD is an angle measure. I still see the letter M for measure, so my answer should be in degrees. Next is YMW, a semicircle once again, 180 degrees. MW is a vertical angle to this angle over here, so if that's 96, this should also be 96. And then last one is XMY. So we can, I like this one. We can take the whole circle. We can subtract 96 to get 264. Okay, that's our real quick Unit 10 refresher. Now let's talk about the differences from this other stuff we're going to talk about. When I look at number 3, the first thing that I see is that it says arc length. That tells me my answer is going to be in centimeters, inches, feet, whatever it is. So I'm going to look at A. The first thing I need to figure out is what portion of my circle am I looking at? And to do that, I'm going to look at the angles. I know that this semicircle means 180. So if I subtract this 60 away from the 180, that angle is 120. If you're good at fractions, you probably know 120 is a third of a full circle. But if you're not super good at fractions, that's okay. I'm going to leave it as 120 out of a total 360. And then I'm going to multiply that fraction by one full circle. So one full circle here, 2 pi r, but I do have the diameter. So let's use the diameter. Let's use pi times d. Circumference. Good? Now I can put this in parentheses and plug that whole thing into my calculator. If you really like exact values, this is your unit because you can leave everything in terms of pi and that's totally cool. But if you like rounding things, I'm cool with that too. I'm going to say arc length equals 120 divided by 360 times pi times 24, and I'm going to get 25.1 feet. That's the length of that little piece of crust. Good? Questions? Okay, let's do, I don't want to do all of these. Let's just do C. We'll move on to C. Okay, so again, we're looking at the length of the crust. I want to figure out how much of the crust am I looking at here. You can spend your time adding these if you really want to. You know, one semicircle is 180. That right angle means 90. What does that add up to? 270. Or the simplified version of this fraction, if we just look at it, we can tell this is 3/4 of my whole circle. Yes? So arc length equals 3/4 times 1 full circle, 2 pi, radius is 6. We plug that whole thing into my calculator. We can simplify it by hand too if we really want to. I got 28.3 meters. Everybody happy with that? Okay, let's do the same thing with our areas. So area of a sector or shaded region, you're either going to see that called shaded region or sector. Again, I figure out what portion of my circle am I looking at. Me, personally, I don't know what 208 out of 360 is off the top of my head, so I'm going to leave it as 208 degrees out of a total 360 times 1 full circle, pi, radius squared. I don't know my radius, but I do know my diameter is 20. So I'm going to divide that by 2 to get my radius is 10. So 208 over 360 times pi r squared gets me 181.5 centimeters squared. Good? Okay. What about this other one? What portion of my circle am I looking at? That shaded region is what fraction? Doesn't have to be simplified. Just tell me what fraction I'm looking at. How do I figure it out? Caitlin? Mm-hmm. Perfect. That's the diameter. So I'm going to take my 180. I'm going to subtract 48 to get, I believe, 132. So then the area equals 132 out of a total 360 times pi r squared. Pi, radius is 3 squared. Put the whole thing into my calculator. I always put that fraction in parentheses, and I get 10.4. Ooh. All good? We got a little bit more, I'm sorry. Flip it over. Okay, quick little word problem, and then I got one more thing I got to talk to you about. So, a pizza has a diameter of 14 inches and is cut into 8 congruent slices. What is the area of one slice to the nearest tenth of an inch? If it's telling me I'm cutting this into eight slices, and I only want to know one out of those 8 slices, what is the fraction that I'm using in my area of a sector formula? I'm not going to sit here and calculate what the degree measure is. I only want 1 out of 8 slices. So my fraction is 1/8 times pi, radius is 7. Oops. So 1/8 times pi r squared should get me 19.2 inches squared. Let's not overthink these too much. If it's telling you it's got 8 slices and you only want one of those 8 slices, you're going to write the fraction 1/8, right? Okay. All right, one last new topic. This one kind of gets lost because it's in the middle of the notes instead of at the beginning of your notes. So I want you, this whole number 6, box it in, highlight it, whatever you got to do. This is our last new topic for this section. This is called area of a segment. It's called area of a segment because it literally has a segment running through it. So AB is like a segment here. And it's just finding, like, imagine you really hate the middle of the pizza. You only want to eat like the garlic butter crust of the pizza. You cut off the whole inside. What's left is just an area of crust. So area of a segment is that idea. It's very simple how we do it because we've already done all of these things before. The first thing that we're going to do, step 1, is find the area of one whole pizza slice before you cut off all the parts you don't want. So to find that area of your pizza slice, I'm going to call this area equals, it's a total of 120 degrees in this problem, 120 out of 360 times pi radius squared. If I do that in my calculator, I do all that math, this area of this pizza slice comes out to 603.2 square feet. Big pizza. Okay, that's the whole shaded region right here, one full slice. Now, I'm weird, so I'm cutting off the bottom of that slice. I don't like the middle. To cut off the bottom, we have to figure out what area we're cutting off. The shape of this area, if you can see it up in this top right corner, is a triangle. They just translated that triangle over here. It's the same triangle. In order to figure out the height of that triangle, they've drawn a line through the middle, which is what you're going to do. So that 120-degree angle that used to be right here is now two 60-degree angles side by side. You see it? We see it? And then if I do the rest of the math there, I get two 30, 60, 90 triangles. This usually happens where you get a nice special right triangle. It might happen once or twice where you don't and you have to use SOHCAHTOA. It's not the end of the world. With that 30, 60, 90, I know that the hypotenuse is 24. So the short leg, which ends up being the height of this triangle, is 12. And then the long leg is we take the short leg and we multiply it by radical 3. So one full base of this triangle is 24 radical 3 feet. Good? Now the area of that triangle, the piece that I'm cutting off, is 1/2 base, 24 radical 3, times height, which is 12. I'm going to put the whole thing into my calculator. I'm going to get 249.4 feet squared. And now, if I know the area of the full thing, I know the area that I'm cutting off, how do I figure out what's left over? I'm going to subtract one from the other. So I'm going to do 603.2 minus 249.4, which tells me that the area of that segment that's left over should be 353.8 feet squared. You will have to do this on homework, on quizzes, on tests, so make sure that you understand this is part of the notes. Let's do one more little quick example. It's really fast. Area of this sector, it's a right angle, so I know it's 1/4 of my whole circle. 1/4 pi radius squared, which is, 38.5. Area of that triangle, each one of these little pieces here in this circle is a radius. They love these kinds of problems. So if that's a radius, this is also a radius of 7. And because of that right angle, 7 is my base and 7 is the height. So the area of this triangle is 1/2 7 times 7, which half of 49 is 24.5. So we're going to subtract them to get the total area of that sector, 14. It's 14. 14. Do I have a unit? Unit squared. That's all. Any questions on that? We understand the idea? Fantastic.